hydrograph. In other words, you are doing this, right? From the beginning of the rain to the end of the rain, you integrate it. You are getting the area under this curve. That is it the same as the total rain? It is not, right? Because not every drop of water that's fallen from the skies in that particular rainstorm has been able to find its way into your river. Some of them has infiltrated. Some of them has been intercepted. Some of them has been evaporated. So what you get is the resulting total volume of the water is what we call an effective rain, not the total rain. Let's call it an effective rain, all right? Versus total rain. Total rain is what you measure, assuming your measurement using your tipping bucket rain gauges were correct. All right. So you have to actually get rid and subtract from the total rain the losses. All right, if you are able to do it. Now there are no rain gauges in the world that allow you to measure directly effective rain. It's just none. How do you get your effective rain? How do you get your effective rain? How do you get your effective rain? You can't measure it directly. How do you get the effective rain? Sorry? Rainfall minus loss. Okay, you can. But how do you measure loss? Then you have to measure evaporation, interception, all those shins that you have. And Professor Tan every year said this question, I should describe all the shins. All right, and then you get which is she asks you in your quiz anyway. All right, the easiest way to get it is to actually measure the runoff hydrograph and integrate it. Okay, that's what we did. We actually did it. We integrated last week. We did it. Integrated. Now, now before you integrate it, you must get rid of it something. What is that? Because what you measured from the storm may not necessarily come from that storm. There is additional water that is inside your river that you are measuring that day. Let's pretend there's a river after this rain. You measure it now. Then let's pretend it rains. Let's hope it rains because it's not so hot. It's terribly hot. And that day you go and measure it. That may not be all from the rain because some of them may be from the ground, base flow. So last week we learned the base flow separation method, right? Remember that? Let's say this is the base flow separation. We take it off. And hey, this is actually from the rain. This lot is from the ground. You have to get rid of those on the ground. So strictly speaking, this guy is the total volume of effective rain. In other words, rainwater from that storm that effectively has become river water. That's what we are actually trying to say. So we did it last week. We started with this. We want effective rain, but we cannot directly measure it. All we have is the total rain. We have this runoff hydrograph, and we do a base flow separation. Remember, we have actually different methods. We have the ratio methods. We have those direct log kind of thing, and then you draw a log curve, this exponential decay curve, and then somehow or other you manage to do your base flow separation. Now remember, this is actually some kind of methodology that people have developed, whether it is real or not, nobody exactly whether it is true or not. Maybe it's very close to being true, but nobody exactly knows whether it is absolutely true or not. But that's all we know. All right. So let's pretend we managed to get this. This is now the effective range, and from here we realize that we can actually get what we call a unit hydrograph. Somehow or other, we manipulate the data from here, and finally we got here. Remember, we've done this. All right. So we also discussed that this unit hydrograph is preceded by an adjective that says this is now an X-hour unit hydrograph. Okay. So it could be a 1 hour unit hydrograph, it could be a 4 hour unit hydrograph, it could be a 2 hour unit hydrograph, whatever hour unit hydrograph. We also discussed how that is defined as a 2 hour unit hydrograph is the direct runoff hydrograph, meaning the hydrograph that comes from effective rain. How many units? 1 unit in the SI system, 1 centimeters of effective rain, effectively distributed, so uniformly distributed over the entire catchment. There's 1 unit. And the 2 hour describe the duration of your rain. Okay? Alright, so that was the background. Now let's play around with this. Let's say now, in this catchment, historically somebody has done the work and got for you a 4 hour unit hydrograph for that particular catchment. It only work for that catchment, it doesn't work for anything else. Alright, you got a 4 hour unit hydrograph and you want to use it, and suddenly you have a storm that comes this way. This is the rainfall intensity time. This is a 6 hour storm. Okay? This is intensity in terms of centimeters per hour. This is what is given to you. This is that rain. Somebody measured that silly rain. Okay? You got it. It's given to you. And your question is, if you got this rain, what is the runoff hydrograph as a result of that rain in this catchment? And what we have is a 4 hour unit hydrograph of that catchment. What do you do? Now this one is only useful if you've got a 2 hour unit hydrograph. Because for the 4 hours, it's not uniformly distributed. Okay? So now you need a 2 hour unit hydrograph. You don't have a 2 hour unit hydrograph, you have a 4 hour unit hydrograph. So what do? You can sit down and wait for some more rain and wait for a 2 hour storm. Now, if you are doing a consulting job, you don't have the money nor the time to wait. You just have to find one. So that's where this unit hydrograph synthesis came to play. You don't want to wait. You don't have the money, the logistics, nor the time to actually play around getting a 2 hour unit hydrograph. So we actually play around with getting the 2 hour unit hydrograph. So let's play around with getting a 2 hour unit hydrograph from a 4 hour unit hydrograph. This is now a 4 hour unit hydrograph. Let's pretend it looks like this. Okay, since you're only 1 person here, we ask you to answer 2 person, 2 person. What does the effective rain distribution curve looks like for a 4 hour unit? What does this thing look like? If you plot effective rain, right? We don't want total rain. Let's pretend we know the effective rain, because effective rain is that gives us this guy. So what is the effective rain distribution that caused the formation of a 4 hour unit hydrograph? What does it look like? Is it correct? How long is this? 4 hours. This is intensity, not depth. So what is the unit of this? 1/4. Thank you. So this has to be 1 unit. In our SI system is 1 centimeter. Alright, this is now a this is the correct effective rainfall intensity that give you a 4-hour unit hydrograph. Now let's pretend we want an 8 hours, forget about 2 hours first. Let's talk about an 8-hour unit hydrograph. So now I want an 8-hour unit hydrograph. What does that look like? Eight hours. Forget about the 4 now. 8 hours. So let's do 8 hours long, right? Okay. 4, 4. 8 hours. How high should this guy be? 1/4, 1/8. 1, right? So it should look like that, right? So this is now another 4 hours. I'll give it in intensity of 8 hours. That guy will be 1/8. Now that would be now easy to do the translation, the synthesis. You got a 4-hour unit hydrograph that looks like this, which was the red color. Now, in other words, now this 8-hour rain is essentially 2 discrete 4-hour rain, right? The first rain starts from here to here, and then it stops. The second rain starts from here to here. Alright? In other words, the second rain starts 4 hours after the first rain. Correct or not? So this block caused this guy. That block, the second block of 4, starts 4 hours later. And then, okay? Correct or not? So if you add this red curve with this black curve, what you get is okay, now you got a green hydrograph. Is this an 8-hour unit hydrograph? Now you go back to what? It's an 8-hour unit hydrograph. What is that? 8-hour 2-unit hydrograph. Alright, there's 2 units. Alright, remember this, when you actually add the 2, you're actually adding this guy and this guy. Alright, so now it's 1/4, this 8 is 2 units, 2 cm now. Correct or not? So in other words, 2 cm, you want to actually get it back to 1 cm, what do? You divide everybody by half, right? So if you divide everybody by half, you get something like that. I'm not drawing to scale, obviously. So that guy now would be a 8-hour unit hydrograph. Got it? Now, we don't want 8. Not just now we have questions, I want 2. So now let's come back to our friend here. You have a 4-hour unit hydrograph. This is 1/4. Now you want a 2-hour unit hydrograph. 2-hour unit hydrograph is this guy, 2 hours. And this should be 1/2. Correct? Now how do you get from the red rectangle to our black rectangle? That's the question. How do you get from a red rectangle to the black rectangle? Can you actually create another one that starts from here to here? Right? In other words, you shift it by 2 hours. Okay, you want 2 hours, you want this guy, right? You want this guy. But there's no use. If you add this red one with the blue one, what you get is something that looks like that. That's a Chinese word. Okay, you got something like that. It's no use. Number one, it's not even uniformly distributed. You can't get anything by doing this. So that's when we actually need to use what we call an S-curve. Remember, this is what we want. Okay, this tall guy is what we want. Thinner, taller guy is what we want. So what do we want? We want to actually create what we call an S-curve. So the S curve meaning that we retain this ordinate, which is 1/4 centimeter per hour, but we want to actually remove the identity of the 4 hours. I don't want 4 hours anymore. So what do? We use this 4 hours, lag it by 4, you create another block. Put another guy, it's all 4 hours, right? 4 hours. And you keep doing it until you go to infinity. Now what you do essentially is that you lose the identity of the 4 hours. You got 4, 4, 4, 4, all to positive infinity. So essentially you got an elongated, long rectangular block with now the identity of the 4 hours or 2 hours or 10 hours. In fact, it's infinite hours. Now, if that still retain 1/4 of it, centimeters. Now, once you got this long rectangle, this long snake, then you can now shift it to any hour you want. Alright? So this is a long one. You shift it by 2 hours. Because you want 2, right? This is the red one that goes to infinity. Now you got the black one that moves to infinity. So you got now, this is one of them. This is the original one. Now I shift the other one to this one. Now if I subtract, remember this end got no end, right? All go to the same place, infinity. If you subtract this curve from this curve, what do you get? If you subtract this black one by the original one, what you got is this guy. Can you see that? That's what you get. Got it? So in other words, what we are actually doing is the original 4-hour unit hydrograph that looks like that. Now if you shift it by 4 hours, 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 and keep shifting it, and you keep adding it to infinity, what you are getting is essentially something that looks like this. Okay, so this S curve is essentially the resulting direct runoff hydrograph as a result of this thing extend to infinity. Okay, so essentially what it is. Now if you shift it now by 2 hours because that's what you want, so this is now shifted by 2 hours. Okay? So once you do that and you subtract the black one from the red one, you got this guy. Something like that. Now, is this a 2-hour unit hydrograph? Is it or not? It is not. Now it's 2 hours. This is 1/4. So this is only half a unit. So this is a 2-hour half unit hydrograph. You want it to be 1 hour, 1 unit hydrograph? Double it. Okay? Now, if you want a 6-hour unit hydrograph, all you need is shift it by 6. If you shift it by 6, in other words, the black curve is now here. Okay, you subtract the black curve from the original red curve. Now you got your hydrograph that looks like this now. Okay, now this is 6 hours. But what is the unit of this guy now, this green one? It's a 1/4 times 6, right? It's now 6/4, which is 1.5. So if you subtract that one from the original one, you got something like that. But that is now a 6-hour 1.5 unit hydrograph. You want a unit? You want everybody? Alright? So that's what we are doing. So the S curve is the most powerful one. S1, you can start with anything and you can get anything you want. But it's time consuming to do because you need to prepare your S curve. The other one, from 4 to 8, it's an easier way to do because all you need is to actually get two columns and start adding. But that method only works for if you start with x hour unit hydrograph. What you can get is really 2x, 3x, 4x, 5x. That means alpha x as long as alpha is an integer. So if you start with a 3 hour unit hydrograph, what you get is 6, 9, 12, 15, 18, 21, and so on. You can't get anything else. Alright, you start with 1 is the nicest. 1 you can get anything you want. Alright, if you got 3, that's what you get. So 4, you get a multiple of 4. Alright, and that multiple coefficient has to be an integer. Otherwise, S curve. Now, does he set S curve in exam? Yes, I've seen him set. Alright, he does. In other words, do quickly. That's the only thing I can tell you to do. I keep warning you guys have no time to check hydrology exam. No time. I guarantee you have no time. You have time means you don't know how to do. You may so walk out. Okay? If you know how to do, you have no time. Every time you press, the first time you press the calculator, you have to press it right. Because you have no time to check. I tell you, you have no time. And then you peep at your neighbor, find out it's different, then you jialat already because you have no time to check whether he or she is wrong or you are wrong. You have no idea. Right? That's the way it is. Alright? Alright, let's do it very quickly because I'm just telling you the background. This is actually what we have done. Given below is a 4-hour unit hydrograph for a basin of 195.68 square kilometers. Derive the S curve and find a 2 and 6 hour unit hydrograph. You see? Start with the 4. If you don't want S curve, you can only get 8, 12, 16, 20, and so on. Right? You know, get 2 and 6, you got no choice. But to do a 6-hour unit hydrograph, now, if in 1.5 months' time, they give you 21 numbers for your unit hydrograph, you are pressed for time. Okay? You have to do really, really quickly to give you 21 numbers. Alright, here we go. It's a pretty long hydrograph. 21 of them. This is the 4 hours. This is the number. This is now time. This one, because the 4-hour unit hydrograph, the time interval here is in material. It does not have to be 4. It could be any number. This is the 4-hour unit hydrograph. This is the S curve addition. Now, hydrologists like to use this, but you don't have to use this. But this is a lot faster because this only creates 2 columns. Otherwise, you do the way that I like to do, but that is because I do it, I'm not sitting exam. I can do it in my office with my Excel. Alright? So what you do is just shifting it, and adding it across. Okay, but this is what they call an S-curve addition. And then this is how you do it. Construct S-curve from 4-hour unit hydrograph. This is the S-curve addition method. Now essentially, we want to actually shift everybody by 4 hours, right? Remember the first block of effective rate, you want to shift it like that, Alright, so the 0 here, start the first point, count 1, 2, 3, 4, and then the 5th one will be, the 1 will be 1, 2, 3, 4, the 5th hour will be, so on. Alright, so that number becomes here, the 4 becomes here, the 25 becomes here, the 44 becomes here, and the next one will be 60 plus 0, this plus this to get this number, this 70 plus 4 to give you this number, okay, and 61 plus 25 give you this number, and so on. This is the S-curve addition. If you don't believe this is correct, you actually go home and start looking at your Excel by actually shifting every hydrograph by 4 hours, next one by 8 hours, next one by 12 hours. You add across, you find that it's exactly the same. Alright, because that's already included in the addition thing. Okay, if you're desperate, you can actually take a photo of this. You want to check it, it's not I moved on. If they want to take, I'm going to press. Okay. This is just to double check your addition, that's all, it's no big deal. Alright? Okay, after that, just add it. Now remember, don't forget to add. Alright, add. Alright, we have added. Now you lag. How long do you want to lag? Remember, we want to do 4 to 2, so you lag by 2. If you want to do 4 to 6, you lag by 6. That's all. Alright? Count the number of things, empty space there. Lag by 2 hours. This is essentially what you get. This is the original 4-hour unit hydrograph, the light blue. You lag by whatever you want to get. You want a 2-hour lag by 2. You want a 6-hour lag by 6. You want a 5-hour lag by 5. Just whatever you want to do. And then subtract 1 from another. Alright? The 0 lag by 2, the 4 lag by 2, 25 lag by 2, and 44 lag by 2. Everybody lagged by 2. And then you subtract 1 from another. Subtract the lag curve from the original curve. Alright, so this is a unit hydrograph. Sorry, this is a direct runoff hydrograph. It's a 2 hours, and this is 0.25. So this is a 0.5 unit hydrograph. This is not a unit hydrograph. So you have to multiply everybody by 2 in order to get it 1 unit. Alright? So then we go. This is a 2-hour unit hydrograph. Quite a bit of time, huh? Normally when he said this, the unit hydrograph will be round about 7 to 8 numbers. Because if he give you 100 numbers, it's all the same anyway, you just stick to it. So. But even for 8 numbers, it's quite a bit to do. Okay. And you want the 6 hours to do the same thing, you lag by 6. Now remember the S curve with the lag, this number is the same, right? This number has got nothing to do with what you lag. Right? This is the original. Alright, from the 4 hours. And then you subtract. And now this is now a 0.25 or 1/4 on the y-axis and 6 hours on the x-axis. So that gives you 1.5 unit of centimeter of rain, effective rain. So you have to subtract, divide everybody by 1.5. So 4 divided by 1.5, 25 divided by 1.5, and so on. Alright. Now, when I know that in the years that he has asked you to do S-curve to create a new unit hydrograph, this is probably just 5-6 marks. But you need this to do the next part. Without this, you can't do. So it's quite sad, huh? Okay. But you should be able to do it. Just do it first. Okay. Now, let's do the second one. The second one is called a synthetic runoff hydrograph. A few years ago, I know a friend. He was originally from South Africa and then he moved to the United States, having a consulting office in Colorado. And one day I received an email from him. He got a job in Myanmar. Sorry, not Myanmar. He got a job in Cambodia. All right, and he need rainfall data. Right, he's like me, dealing with water. He asked me, do I have any rainfall data of Cambodia? I said, no, I don't have. I'm Singapore. Do you want to pretend Singapore has the same rainfall pattern as Cambodia? He said, Singapore a bit different. Huh? Singapore is so non-rural, so urban. Dare not use it. So I said, Malaysia, close enough. I may be able to get some from Malaysia for you. Then I said, I also know friends in Vietnam. I may be able to get something for you in Vietnam. He said, Vietnam sounds closer. Would you use Vietnam or Malaysia for Cambodia? Alright, yeah, Vietnam is closer, right? Let's pretend Vietnam. So he got Vietnam. Alright, so I give him Vietnam data and I don't know what he did with it. He didn't even buy me coffee for my effort. Okay, so bad. Alright, because his job and his income depend on that number, right? Now, if you don't have those numbers, you're doing, say you got a job in Laos or something like that, and then you have no data, for goodness sake. And you got a friend in Cambodia or Yunnan or something like that and pretend they are the same. Otherwise, you get a synthetic unit hydrograph. Synthetic means make up, right? Make up, you make it up. You don't have those curvy things. So a synthetic hydrograph, runoff hydrograph, or what we call cinder, essentially is a unit hydrograph that is based on a triangular distribution. Alright? We start with a 0, 0 point. This doesn't work. Okay, so you got a peak, which you got the time to peak, and then you got your Q peak, and then you got a base. Essentially, you're looking at this coordinate, and you're finding this coordinate. You're actually trying to get this number, and this number. That's all. Triangular distribution. Cinder. Alright? Now let's be honest, cinder is more somewhere. Alright? Its data, probably Europe, probably America, I don't know. And you know for sure those rain is not the same as our rain. Cannot be the same. If you go to England, it rains forever and drizzling. Here for us, bomb finished out in the war. So cannot be the same. But when you are desperate in consulting, anything you think about, you got no choice. You have to get the money, right? You have to get it done. You know how to get it done, but you have no raw data. Alright, so you just whatever you find, you just get it. Alright. So here it is. You use the Cinder's runoff, Cinder's unit hydrograph. Synthetic unit hydrograph. And I don't like this because it is actually, has he said this before? He hasn't. Actually, it's very easy. It gives you a bundle of equations, and you substitute and get those three coordinates. That's all. The only thing that you need to do is to know what each of those symbols represent. That's all. Okay. It's like when you're in lower secondary school, they give you some equation, you don't know why and where it comes from, and then you put the numbers in, and as long as your calculator works, you've got no marks, right? It's just like that, all right? Now, I mean, we are no longer in lower secondary school, but so if you want to read cinders, I do not know how much information he gives you on cinders synthetic unit hydrograph method, but I suggest you can actually read it up. And you can read a book. I realize that you guys in this generation do not read books, you read Googles. So whatever it is, then you just Google something and read it. If not, go to the library and get an authentic book, all right? A real book, because Google sometimes don't use the one with an AD in front. Those are advertisements, you know. So they are not true ones. You know. They are just telling you all things so that you can buy their things or go inside and see their things. Right? Don't read those things with an AD, the advertisement. So here we are, just follow this cooking recipe. Alright, it will never make you a master chef, but you will something come out, probably won't die eating it, but it will never be a Michelin star chef, alright? But in Singapore, even selling chicken rice can be Michelin star. I don't know how can be Michelin star selling chicken rice. And what's given by some white people who doesn't know what chicken rice looks like. You know there's a master chef guy who's actually judging a guy cooking in the competition. The judge says that, how come your rendang is not fried?
Oh my god.
Crispy,
And then the guy lost. It's a Malay woman or Indian woman, right? Who cooked that from the and the Angmo judge says that your food is very nice, your rendang is not deep fried. But who deep fries beef from cooking rendang? Nobody. So alright, don't forget about people judging, right? So in other words, French guy judging what your chicken rice should taste like. You know? How can, you know, they don't even eat our kind of food, right? Anyway, so cooking recipe, follow it. I don't think Professor Chin, if he asks you to do this, will ask you to memorize those equations. Huh? If he asks you, I tell you which car he is, you can scrape this car, right? You can scrape this car. Otherwise, how can nobody remember those equations? Nobody in their right mind remember those equations. After I say that, I shouldn't be so loud, just in case this year I ask you to memorize it. But then don't blame me, huh? Okay, you ask him. Okay, at the end of the day, you get something that was. Alright, so I won't go through it. I just want to keep going. Alright, that one is just a cooking recipe. Just follow those numbers, equations that Mr. Sinder derived. Alright, use the following 4-hour unit hydrograph. This is a 4-hour unit hydrograph and find the peak flow from 4 successive 4-hour periods of rainfall, producing 0.89, 2.21, 3.53, 1.96 centimeter of runoff, respectively. So how long is the rain? How long is the rain? From the beginning to the end of the rain, how long? Huh? How long is the rain? 4 successive 4-hour periods. How long is the rain? This English very poor, this group of people. How long is the rain?
4 hours.
4 successive 4-hour period of rainfall. How many?
6.
I thought your English is bad, your
16
arithmetic is bad. 4 times 4 is 16, for goodness sake. 16 hours of rain. But why is 4 hours so important? Why did the question emphasize on the 4 hours? What can you produce a 16 1-hour period? Because within that 4 hours, the rain is actually considered uniformly distributed. Alright? So for 0 to 4 is the same uniformly distributed. From 4 to 8, uniformly distributed, 8 to 12, and so on. Okay? Next word. It's all English word, very important. 0.89 centimeter of runoff. What on earth is that? He didn't say 0.89 centimeter of rain. He said 0.89 centimeter of runoff. What does that mean? What does that mean? This group had migrated there. What does that mean? What do you mean by 0.89 centimeter of runoff? What is that? Is it runoff or rain? Effective rain. Those are the rain that has become runoff. Okay? In other words, if you want to do it, is actually to get those direct runoff, those runoff, and subtract the base flow and divide it by the catchment area. That's essentially what it means. Alright? Now guys, warning in the exam. Check this unit. Sometimes it's cm, sometimes it's mm, sometimes it's cm per hour, sometimes it's mm per hour. Sometimes this is given to you as effective rain, sometimes it's given to you as total rain. If it is total rain, for goodness sake, subtract the losses. Okay, we want effective rain. Okay? Okay, ignore base flow. There is no base flow in this river. In other words, whatever that comes from the skies will be river water. I'll ask you to determine that. So this 4-hour unit hydrograph, you don't have to do unit hydrograph synthesis. You can just directly use it. So no waste flow. So runoff equals to rainfall. Unit hydrograph is for 1 centimeter of rain. You got 6 centimeter of rain, 4 times unit hydrograph, that give you the respective things. So 0.89 for the first one, 2.21 for the second one, 3.53 and 1.96 respectively. Alright? So be careful with this thing. Huh? If you give you per hour, you jolly well have to convert it to the total rate, effective rate. So the 4 consecutive 4-hour period is considered 4 discrete storms. The first storm Start with 0 hour, end at 4 hours. Second storm start with 4 hours and end at 8 hours and so on. Alright, so they are the 4 discrete ones. You calculate them as discrete rains and then add them up together. Alright, so this is a unit hydrograph. And the first rainstorm, Q1, the rain start with time equal to 0. The second rain start with the time equals to 4 hours later. So which column is that? 5 or 4? 4. Alright, you have to jump 4 space. 1, 2, 3, 4. The 0 comes here. 16 comes here. Alright? For the second rain. Okay, so the first rain is now 1 hour is 0.8, sorry, it's not 1 unit, but it's 0.89 unit. So everybody times 0.89. Second one, everybody times 2.21, except this 0 comes 4 hours later. Jump, jump, jump. Here will be a 0. Okay? And everybody else times 2.21. Third one, start with 8, and everybody times 3.53. The fourth one start at 12, everybody times 1.96. There are actually now 4 storms, and the total rate is add them up together. Please, for goodness sake, don't add your unit hydrograph. That's not the number, just this. 0, 14, 52, 154, 300, 392 plus 35, and so on. Okay? Are we alright? So that's all. Now, it's not that difficult to do. The only difficulty is that you have the time to do it. I keep warning you, you have no time to check. Don't think about checking. If you got the time to check, that means he said that you're so easy. Even easy also have to have time. Okay, the peak is 1980, and time equal to 18 is 1250. Now, if he didn't ask for these 2 numbers, you have to keep going. Right? Because there isn't end yet. Because this guy still has a bit more to go. So as this guy got a bit more, there hasn't reached the end yet of the ring. Any questions? Alright, the last final question. Sometime, I told you already, this unit hydrograph stuff, one way or another, bound to come up. Bound to come up. There's just no question about it in the exam. It's bound to come up. Whatever formula they say will come up. One question will come up. Because if you check the last 20 years past year exam question, it is there. Every year is there. I can tell you frankly it's going to come up. It's just whatever way he said it. One year they said it's so strange, he doesn't give you numbers. He give you all symbols. And it's very frustrating to do. Sometimes symbol, and every column is some stupid symbol inside. T over don't know what, and then, wow, that one even more jialan. I remember 2 years ago is that. It's the same, but except that now you have to write in symbol instead of number. In other words, don't need to do calculators. Sometimes you remember without the calculators. You have to write everything down. Okay, this is a 6-hour unit hydrograph for a given catchment. Following table, this is a 6-hour unit hydrograph. Compute the outflow hydrograph from this catchment for a storm Nana. The storm is given to you not in total depth, but in intensity. The intensity is not important as far as the unit hydrograph is concerned. It is the total depth within that duration. If it is 6 hours, within 6-hour duration, what is the total depth? Alright, the first 6 hours, second 6 hours. So it is a 12-hour rain. Alright? The first 6 hours uniformly distribution of 20 mm per hour. This is nevertheless not an effective rain. This is a total rain. So you have to subtract from it the losses. How much loss? This question is pretty nice. It tells you it's uniform loss. He did not give you a uniform loss. He can give you exponential loss. Completely up to him. He's uniform. So every miserable hours, 14 mm get out. So for the first 6 hours, how much rain has fallen from the sky? 2 centimeters times 6. But the effective rain is 20 minus 14, that means it's 0.6 centimeters times 6. So it's 3.6 cm. Likewise, for the second one, 23 minus 14 and multiply that by 6. Remember, convert your unit to cm. Huh? Don't leave it as mm. Now, if you give you meter per hour, for goodness sake, you know what to do. If you give you per minute, per year, per month, just convert it to per hour and then accordingly deal with it. Alright, and now there's a constant base flow. It's also nice. That means what oozes out from the ground to actually add on to your rainwater is actually 13 meter cube per second. So let's do it. Now this is the type that you will normally, the extent of the unit hydrograph, that number 1, 2, 3, 4, 5, 6, 7, 8 numbers is probably more like the exam length of the unit hydrograph. Alright, he won't give you 21 because it's a long time to do without doing a calculator, without Excel. Alright, first deal with the rain. This is unlike the previous question which tells you directly the effective rain depth. This one give you intensity, moreover is not an effective rain. This is the total rain, this is the loss. Okay, you get your net rain per hour. So this subtract from here is 6 over 6 and 9. And then every storm is 6 hours. You need the total depth of the effective rain. So this times, this becomes 0.6 times 6, 3.6 cm, 5.4 cm. Okay? Alright, there we go. There are actually 2. Now this is more like exam kind of question because there's enough time to do. Okay? The other one you won't be able to do it because there are actually 4. And then 21 numbers. It's take a long time. Okay? The first storm, which is 3.6, so you start from here and go on. Okay? The second one starts 6 hours later. So everybody just select by 6 and multiply 5.4. And the flow rate is constant, 13 from the ground. And add column Q1, Q2, and base 2 together. And get the number. I hope you realize that this is not difficult to do at all. If I were a student still, I'll do this first. I'll do it first. Get it out of the way, I know I get 3 marks if I don't press anything wrong. If you press anything wrong, nobody to blame. Blame the calculator. Okay. There was actually last year in hydrology, one girl sitting right in front put her hand up. Sir, my battery is dead. How? Sorry. So she wanted to borrow from Miss Chloe Chan. So nothing to lend. I only have one how to lend. Don't let that be. Don't be like that, huh? So how many calculators did you bring into the exam? 2. That's 2. How many do you bring in? 2. 2 not kiasu now. 5. 1 only
So what calculator multiple batteries?
Okay, one question. Next tutorial will finish everything. We have 1 more week. Do you want me to do past year exam question or do you want to call it off?
Past year.
Last year. Past year. Last year.
Past year.
Don't have time for past years.
Last year.
Last year.
Last year.
You want to do last year or the year before? The year before? Don't go so far back because Shelson wasn't even here yet. But he has been here for 9 years already, so got lots of time.
Last year?
Last year? Last year. I don't think we have time for 2 years. Alright, there are 4 questions. Alright, so we'll try. I'll take it out and see what I can do. Okay.